MOXIE Media Incorporated presents Lifeboat Operation and Survival Practices, an in-depth introduction and orientation to your primary means of escape in a platform, rig, or shipboard emergency. In the majority of emergency situations, the lifeboat is the most frequently used means of escape from an offshore oil installation or ship. It may be referred to as a life capsule, a survival craft, as well as a totally enclosed motor-propelled survival craft, or TEMPS for short. For the rest of this program, we will usually refer to it simply as a lifeboat. There are several manufacturers and types of lifeboats used all over the world. However, once in the water, they operate under the same basic procedures. The biggest differences lie in the boat's launching systems, which are made up of three main types: the single wire, double wire, and the big splash of a free-fall system. The properties of enclosed lifeboats that make them so advantageous to abandoning personnel in a fire, blowout, toxic gas, or collision-type emergency are set under international convention and national laws. These features include a rigid watertight hull that is fitted or injected with polyurethane foam, making it virtually unsinkable even when fully loaded, flooded, and open to the sea. A coat of international orange paint on the hull and enclosure to provide high visibility for easier detection. With all doors and hatches closed and personnel evenly seated with their seatbelts on, the survival craft should be self-righting. Tougher new SOLAS, Safety of Life at Sea regulations, call for the craft to allow above-water egress, even if passengers are out of their seats and the boat is flooded. A propulsion system, generally equipped with a marine diesel engine, capable of sustaining 6 knots with a full complement of passengers for up to 24 hours. The hull and enclosure is manufactured with fire-retardant reinforced fiberglass that becomes fire-resistant when the lifeboat's sprinkler system is activated, bathing the exterior of the craft with seawater. And the ability to escape through areas of toxic gases with a self-contained air system capable of sustaining up to 10 minutes of operation. This system allows the engine and escaping personnel to function normally while providing a positive pressure to the craft's interior to prevent toxic gases from entering. Now, for the purposes of this video, we will only briefly identify some of the more popular davit, winch, and releasing mechanisms used in the launching of lifeboats on offshore installations and ships. Although each installation may differ in the number of wires, also called falls, lines, and cables, which are used to lower survival craft, they all utilize davits to hold the lifeboat in place and to use as a means of lowering the craft over the side, a winch to recover the lifeboat, and a releasing mechanism to release the falls from the boat, allowing the lifeboat to escape. It is your responsibility to learn the exact launching procedure for the equipment used at your facility. You won't have time to learn in an emergency situation when one false move could mean your life. As seen earlier, launch systems come in 3 basic types. Shown here, we're looking at a Harting lifeboat, utilizing a free fall method of launching, which allows the full complement of personnel on board to release quickly and fall into the sea. Personnel are seated backwards and tightly strapped in to provide the best possible protection against the impacts of launching from heights of up to 120 feet or 40 meters. This design allows the craft to move safely away from the vessel or platform at a speed of 10 to 12 knots without engine power. The free-fall boat can also be launched by means of a controlled gravity lowering system, as well as in a float-free configuration. A single-line launch system, which is found on Survival System International capsules, or what was once known as Whitaker, provides an efficient launch means during an emergency, as well as ease of recovery of the craft during training. The rounder shape of these capsules provide 360 degrees of clear visibility and the ability to turn 180 degrees in less than the capsule's length at full speed, making it easier to get out of trouble quickly around rig and platform legs. A double-line launch system utilizes 2 wires to lower a lifeboat to the water below. Shown here is a Shat watercraft lifeboat being deployed. The double-line system provides directional control of the craft when waterborne to ensure a rapid getaway, even in hazardous conditions. Davits are required to raise and lower just about any type of lifeboat found aboard offshore installations and ships. They provide the means of holding the lifecraft far enough away from the structure, even under conditions of adverse list or trim, to enable the craft to be safely lowered to the water. An outrigger-type davit consists of a welded fixed structure which supports the winch and lifeboat over the water, allowing for a direct descent to the water surface. It is primarily found on mobile offshore drilling units or offshore oil platforms. A widely used launch system on ships with totally enclosed lifeboats is the Miranda Gravity Davit, which, when activated, lowers a cradle along inclined trackways into the water. The cradle, with its rollers, provides protection for the boat and will operate in both inboard and outboard list conditions. No matter what type of launching system, a winch is used to lower and raise the lifeboat. Gravity lowers the craft to the water, and a motor is used to raise it back up. There are many types of davit systems used on ships and installations. Know how yours operates. To start any launch sequence, you must release the brake by pulling on a cable, or the brake can be released directly at the winch. Some winches are designed so that the operator can stop the descent while others commit you to the water. A gravity descent operates at 2 to 3 feet per second. The winch, most often driven by an electric motor, is also used to recover the boat back into its davit system. Limit or proximity switches are used to stop the winch motor as the boat approaches the stowed position. A hand crank is used for the final few inches. One of the most critical components of a launch system is the cable release mechanism, which is utilized to release the lowering line or falls once in the water, allowing the lifeboat to quickly motor away from the danger area. Release mechanisms fall under 2 categories. The first is an on-load release, which, when activated, will release the craft at any time, whether it is in the water or still dangling in the air. Extreme care obviously must be taken when launching the boat to not inadvertently activate this mechanism. The second releasing system was designed to avert any potential accidents caused by premature release. The offload releasing mechanism is safer because the hooks will not release until the weight has been taken off the cable as the boat enters the water. A manual on-load override is provided in case of a malfunction. Since the releasing mechanism is the key to a speedy and successful launch, crew members should be instructed and trained on all types of releasing mechanisms found at their installation or ship. The regular testing and servicing of release equipment is a requirement and must be complied with as per manufacturer, company, and local regulations. Ship, rig, or platform personnel should be trained to perform regular maintenance on their systems. When an alarm goes off, you should be able to immediately identify the type of emergency. If abandonment of the installation is signaled, you need to determine without hesitation what your course of action will be. Gather any personal protective equipment, such as a life jacket, an immersion suit, warm clothes, a flashlight, and a radio. Your station bill will point out which lifeboat station you're assigned to muster. This information, along with the route to a secondary station, should also be second nature. On your way there, be aware of any potentially hazardous areas of the installation and stay clear if danger is indicated. An announcement may be passed over loudspeakers to instruct you on which lifeboat stations will be used for abandonment. When possible, the installation's lee lifeboats should be used so that when launched, they will drift away from the rig or platform. If a boat is launched on the windward side, the boat must be turned and driven away as rapidly as possible to avoid drifting into the structure. If possible, wait for instructions from the person in charge on which lifeboats are to be used. His or her decision will take into account other considerations, such as toxic gas, fire and smoke, listing conditions, and how much time is available for abandonment. The totally enclosed lifeboat is your first choice of abandonment options if evacuation by supply vessels or helicopters is not practical. The lifeboat should be utilized before attempting any other means of escape, such as life rafts, life floats, or water entry. Once gathered at the muster station, the lifeboat will begin to be readied as a roll call by name is made. The lifeboat commander, also known as the coxswain, is a crew member who has been thoroughly trained on the launching and operation of the lifeboat. He should make it clear that he is in command and that his orders are to be followed to the letter. This should give everyone confidence in their ability to successfully abandon the installation. Ensure that everybody is present, fully briefed, and properly dressed in immersion suits or warm clothing and life jackets. Any missing personnel should be reported to command. While roll call is being held and before boarding and lowering, the coxswain or other qualified persons should be following these steps. All wires, guardrails, and maintenance pennants cleared for lowering. Inspect the hull and enclosure for damage, and be sure there is clear path for descent to the water. Open and secure the hatches and enter the craft. Make sure that the drain plug is fitted securely. Ensure the air support system is operational by checking valve positions and gauge pressure, being sure not to waste the supply by keeping it off until launch is underway. Prepare the water spray system for operation in case the lifeboat encounters incendiary conditions during the evacuation. Ensure that all doors and hatches are secure except those needed for access. Check on the engine starting systems. Many motor-propelled lifeboats will have two methods of starting the engine, either electric, hydraulic, or manual. The commander and other crew members should be fully trained in their operation. Begin the engine startup procedure by checking that the fuel valves at both the tanks and engine are open. Ready the engine controls by placing the gear shift lever in neutral and throttle at full. Check that the engine stop lever is now in the start position. If necessary, place the cold start or excess fuel device in the on position. Again, if applicable, check that the decompression levers are in the start position and that the hydraulic start accumulator pressure is charged for starting. And finally, start the engine up. In a critical situation, board at once. However, if time permits, personnel may board after the engine has been started. If any delay occurs once loading has been accomplished and before the order to abandon is given, the engine may be stopped to prevent overheating. The engine temperature gauge should be carefully monitored. Once the order to load has been received, the commander should direct the procedure. Ensure that personnel are evenly distributed and seated on all levels of the lifeboat. This will enhance the craft's self-righting capabilities and give the lifeboat commander the greatest possible control of the boat. All personnel upon seating should strap themselves in and remain secured in their seats with life jackets fastened, unless delegated by the commander to operate equipment. Unless there is reason to believe that command on the installation or ship is either dead or unable to communicate, it is important to wait until word has been given to launch the lifeboat. Once the order to abandon has been given, all haste should be made to launch, first taking these crucial steps. Check wind speed, direction, and sea state. Make sure all hatches and access doors have been closed. Know the compass course to clear the installation and to achieve a safe rescue position. It is very likely that the commander's visibility will be hampered by either smoke, fire, darkness, heavy rains and seas, or the water spray system. Check the compass heading while still on the davits. Make sure the helm is in the correct position to clear the installation once the boat is in the water. The commander should brief all personnel to stay calm as he or someone assigned by him commences the launch by activating the brake release mechanism. The boat will lower on its fall wire or wires at a controlled rate of speed. If the commander suspects that the atmosphere surrounding the installation is threatened in any way, the air support system should be started by opening the appropriate valve. Once the boat is floating on the water, the commander or assigned crew member should operate the release gear to release the falls from the boat. Place the engine gear lever in forward or reverse with throttle up, taking the boat out of immediate danger. If a predetermined heading is not available, head on an angle 90 degrees away from the installation. Once clear of danger, head upwind at a course 30 degrees off the wind and waves for a distance of 1.5 miles. Upon reaching this site, the boat should heave to under power and wait for assistance. If the craft were to become disabled or lose power, a sea anchor could be streamed or assistance given before the craft drifted back into a danger area. Some exceptions to this procedure might include first assisting other lifeboats and life rafts who are unable to maneuver and drifting into danger, and recovering personnel in the water. If it seems that personnel in life rafts are having difficulty clearing the installation, it is possible to tow the life rafts away from danger in a procedure known as shepherding. Once a safe area has been reached, any injured should be given first aid and communications established with rescue services, who will provide information on the best methods of rescue depending upon prevailing conditions. Once clear of the installation, the biggest danger to the capsule is the loss of watertight integrity. If doors are not kept closed and dogged, rough seas may permit water to enter the capsule, causing flooding, loss of stability, and capsize. The handling of the survival craft, once in open seas, requires expert seamanship by the lifeboat commander in order to reach a safe evacuation point. There are three basic conditions that the coxswain will have to contend with: running in a beam sea, running before the sea, and running into the sea. In a beam sea, the waves are acting directly on the boat's side, and in high seas could actually roll some boats over. If the course required for evacuation requires running in a beam sea, it might be best to change course slightly to take the seas off the bow or quarter in a zigzag type course. Running before is the term used to describe the boat moving in the same direction as the wind and waves. The rudder and propeller can be lifted clear of the water as the stern is picked up by the approaching wave. By slowing down as the seas overtake the boat, it may prevent the stern from being caught and swung into a dangerous broadside position. Running before heavy breaking seas should be avoided if at all possible. In high seas, running into the sea will cause the boat and its passengers to take a severe pounding, as well as risking engine problems as the propeller is lifted in and out of the water. Again, by slowing down and taking seas at an angle of 30 degrees to 45 degrees off the bow, the boat will begin to roll and pitch instead of just pitch. If unable to make headway and there is a chance of capsize, the coxswain should try to put his lifeboat in as stable a position as possible by heaving to, heading into the wind and waves, and utilizing sufficient power to maintain that heading. In the event that the lifeboat were to lose power, it will almost immediately begin to put its largest face to the seas, turning broadside and running the risk of capsizing in heavy breaking seas. This is often called broaching. By deploying the sea anchor, it is possible to prevent the boat from broaching, keeping the bow heading into the wind and seas. It will stabilize the craft and reduce its drift rate from the main search area. A sea anchor, also called a drogue, is constructed in the shape of a pyramid or cone. At its mouth is a bridle, to which a painter is attached, and which takes the strain when the sea anchor is deployed. A line attached to the head of the sea anchor, called a trip line, is used as a recovery line. To deploy the sea anchor, attach the painter to the lifeboat's front hook, or the pad eye below the forward door, and walk around flange. On the windward side, lower the sea anchor into the water using the trip line, and continue to let it out until the line is streamed. The painter will eventually take up the strain, and the craft will come around into the seas. If the sea anchor is ever lost or damaged, a bucket, piece of canvas, or some other suitable material can be rigged as a substitute. If it becomes necessary to deploy a sea anchor, make rescue craft and other lifeboats in the vicinity aware of the situation so that they may render immediate assistance. If your lifeboat has been disabled, towing by another vessel may be possible under certain sea conditions. Rescue vessels attempting to tow a lifeboat should utilize extreme care, approach from downwind with a tow line readied at the stern, and toss the line to lifeboat personnel as the vessel slowly passes. On boats of this type of design, a tow line should be slipped over the bow hook and secured. With the rounded survival system's Whittaker lifeboats, the tow line is attached to the rope bridle on the fore end. Never attach the tow line to a lifeboat's lifting hook, as this could cause the capsule to be pulled over and capsize. The rescue vessel must keep moving forward at a rate not greater than 6 knots to prevent the tow line from ensnaring in the propeller. The tow line should be of sufficient length to prevent sudden surges. If the towing vessel is at the crest of a wave, the stricken lifeboat should be at the crest of a wave. Any course changes should be gradual, so as to prevent too great a strain being placed on the tow line. A zigzag course may prove more effective when it's desired to make headway into the weather as opposed to a head-on approach. Rescue and transfer from the lifeboat via helicopter, fast rescue boat, or standby rescue vessel will be attempted only if the weather conditions and seas permit. If any doubt exists, it is recommended that personnel remain in the relative safety of the lifeboat before putting lives at stake with a dangerous transfer. This decision should be made by the capsule commander only after a thorough assessment of the risks involved. Upon approaching and transferring to another vessel, the captain of the rescue vessel and the lifeboat commander must coordinate all efforts in order to minimize miscommunication and assure success. If mooring to a vessel, use only the available pad eyes located on the lifeboat's flange. Never moor the lifeboat with lines from any point above the walk-around area or flange. The hooks on top of the lifeboat are equipped with pad eyes, and when fully closed and locked, can be used to hoist the lifeboat to a rescue vessel through the use of a crane. Once it has been decided that a transfer is to be made, a lifeline will be attached. Passengers should remain strapped in their seats until it is their turn to leave the lifeboat or to assist in transferring any injured personnel, who should be moved first. When departing, leave in a controlled manner, keeping the weight evenly distributed. If a helicopter rescue is attempted, you should try to make radio contact with the aircraft. Head on a course, preferably to the right side of the helicopter, where the pilot and hoist personnel can best keep you in sight, which will minimize motion to the lifeboat. The pilot may ask you to change your course and speed, depending on sea and wind conditions. A basket will be lowered to the lifeboat, which the hoist operator will ground first to the water before bringing to the cabin entrance. A helicopter builds up a potentially dangerous static charge, which must be removed prior to contact with personnel. If the transfer is to take place at night, light up the capsule's doorway, being sure not to shine the light up at the helicopter. Move personnel with their life jackets on, one at a time, to the door area. Be sure that no one secures the hoist cable to the capsule while persons are being secured in the rescue basket or Stokes litter. Pay attention that the basket does not swing back into the boat as it rises. The position of lifeboat commander is a great responsibility. If it becomes necessary to launch a lifeboat during an emergency, the lives of those within will be riding on the ability of the commander to carry out his duties with speed and diligence. It is for this reason that the lifeboat commander should be well trained for his position, including knowledge of the boat's systems, skilled in handling the craft, and ability to plan for the worst, including weather, fire, injuries, and equipment failure. It is also important for all personnel working on ships and offshore installations to be trained in lifeboat operations by qualified instructors to ensure an orderly, panic-free abandonment and be able to fill in if the lifeboat commander is missing or injured. Frequent training and drills ensure that personnel can perform their duties quickly and effectively, and that the lifeboat and its support systems are functioning as designed. All survival craft should be partially lowered 10 to 15 feet and their engines started once each week, which can be done during regular abandoned ship or platform drills. Once every 3 months, all lifeboats equipped with a full crew should be launched, fully operated, and retrieved. This drill shall occur only during clear weather and sea conditions. The sprinkler system, the engine, the air system, the lifeboats and installations radio communication system, and the standby boat's level of preparedness must all be tested. Check that the installation's radio frequencies and the compass headings of the closest safe refuge are accurate and prominently posted in the survival craft. Hopefully, you will never have to utilize a lifeboat to escape from a marine emergency. But if a life or death situation arises, it will come swiftly with very little time to prepare. With proper training, you will be less likely to panic and more likely to react quickly and decisively. Your skills and positive mental state will enable you to more effectively work to save your own life as well as those around you.